this new GWAS study does not mean that the genetics of psychiatric disorders are simple. These researchers say there seem to be hundreds of genes involved, and the gene variations discovered in the new study confirm only a small risk of psychiatric disease. So what are we looking at then? We're looking at 4 genetic glitches that can nudge the brain along a path to mental illness. But what do we make of the fact that the same mutation can have radically different effects on different people? The answer is likely to be that which disease, if any, develops is going to depend on multiple other genetic or environmental factors. Brings us to this key question, the genotype versus phenotype. Does genotype determine phenotype? Does your genetic constitution determine how you turn out? I've given a sort of begrudging answer here. Yes, but genes are redundant. You knock out a gene and another gene can take its place because it has overlapping function. You quite often find that. So you've got lots of genes involved as team players in a particular activity. One can take the place of the other. But gene products interact. They have to interact. It's from all the interactions of your gene products, all the enzymes of things, all the hundreds of thousands and millions of chemical reactions they catalyze, that you get the emergent property of life. Many of our proteins are assembled into molecular machines, which have to function as teams. Machines such as the ribosomes, the cell's protein-making factories. Other proteins are in metabolic pathways. The product of one gene is the substrate of another. So we can do one of our little figures here for that. I've got my enzymes, which are components of a metabolic pathway, and they're very likely to be lined up on a membrane because evolution has selected for them to be lined up on a membrane. So they're conveniently accessible to each other. And here's enzyme 1, 2, and 3. And enzyme 1 has a substrate which comes down, and the enzyme turns that substrate into a product. And that product is the substrate for enzyme 2. And enzyme 2's product is going to be the substrate for enzyme 3. These genes, these enzymes, are working as team players. They're functioning together. They provide a conveyor belt. What happens if I knock out one of these genes? Well, if there's no redundancy, if I can't replace the enzyme encoded by that gene with another enzyme, I've knocked out a whole conveyor belt, a whole metabolic pathway. This is what happens when gene products interact. We call such processes where one gene steps on the other, is required for the other's activities. We call that epistasis. And my colleague, Dr. O'Brien, has already mentioned epistasis to you. It's a big principle in genetics. So, gene products are redundant, gene products interact, and this, the last final kicker. For many genes, the environment plays a critical role in determining phenotype. You may have a particular allele, which could be devastating for you, but it never gets switched on. It might switch on in someone else when they confront a stress you're lucky enough to miss out on. And stress is the key word here. You could be fine left alone with your particular alleles until a stress comes along and switches on those alleles. Then you're undermined in a devastating fashion. Environmental stresses even play a role in the expression of some monogenic diseases because stresses make them much worse. The example here, cystic fibrosis. Cystic fibrosis is a classic genetic disease. Patients with cystic fibrosis produce a lot of mucus in their lungs, but that mucus is a great breeding ground for this very unpleasant bacterium called Pseudomonas aeruginosa. And the bacteria causes a lot more coughing and even more mucus. So for many patients with cystic fibrosis, the symptoms of their condition are due to a combined action of the mutation and the bacteria working together. Well, okay, let's get back to the question of why do we behave as we do. Many psychologists believe personality traits can be categorized into the big 5 classes: openness, conscientiousness, extroversion, agreeableness, and neuroticism, which they call OCEAN. And these themselves are about 50% genetic and 50% environmental. Some recent meta-analysis, which you may have heard, suggests that a meager few percent differences in personalities and behavior is due to parental influences. And the effect of families largely disappear as people get older. So criminal parents are more likely to produce criminal children. Yes, but not if they adopt the children. Likewise, the children of divorced parents are more likely to get divorced. Yes, but only if they are biological children. So many people have been kind of shocked by these studies. But families do matter. A happy family gives you happiness, and truly awful parenting can completely warp your opportunities. Sandra Scarr, who's a champion of the idea that people pick the environment to suit their characters, puts it this way: parents' most important job is to provide support and opportunities, not to try and shape children's enduring personalities. And Matt Ridley, in his influential book, Nature via Nurture, says, a family is like vitamin C. You need some to stop you getting ill, but once you have it, consuming extra doesn't make you healthier. In the Western world, at least, peers may be more important than parenting. So, for example, if you're a first-generation immigrant to a country, do you speak with your parents' accent or that of your school friends? Well, most likely you said your school friends, because we adopt the mannerisms of our peers. There's evolutionary reasons for this. Your peers are going to be your lovers, your allies, your rivals. In the long run, they're going to be the ones who actually matter to your success in life. Well, it follows from what I just said that the figure of 50% for environment, I gave for environmental influences, that's just an average. The extent environment matters is going to depend on the environment you're in, but people are not passive recipients of environment. They'll pick an environment that suits them, that nurtures them. You may have heard of studies done by social anthropologists who have someone pretend to be dead. In a big city, the presumed corpse, people will walk around it, walk over it. Okay, they'll ignore the corpse. But someone pretending to be dead in a little village is going to be surrounded by people. The smaller the village, the nosier the residents. So in the village in this figure, the impact of genes are going to be small because you have this huge shared environment. Everybody knows who you are, everything you do has witnesses. You spend a lot of time conforming to other people's expectations. Perhaps you never become truly yourself. So that's why many people move into the cities, where they can be much more anonymous, where they'll find people with their own predilections. So the role of genes in cities is going to be greater. The same sort of progression happens as you age. When you're young, you're subject to the whims and moods of everyone else, because everyone else is bigger than you, particularly your parents, and you have to conform to others. But as you get older and become independent, the shared environment becomes smaller, and you become more truly yourself, as determined by your genes. This probably explains a common observation that identical twins reared apart become more alike in personality and IQ as they age. So the media often suggests that there are genes specifically for addiction or criminality and the like. Well, the results of many studies, a plethora of studies, support the conclusion these behaviours are indeed heritable. But not because of specific genes for criminality, addiction, religious beliefs, or politics, but as a side effect of the genes. So what's passed from parents to child is a tendency towards a group of behaviours in a particular environment. You don't have genes for addiction, but you do have genes leading to an impetuous, risk-taking and rebellious personality that can be associated with drug-taking. So, give an example. Twin studies suggested opinions on a long list of issues, from religion to gay marriage to party affiliations, have a substantial genetic component. And neuroscientists have also got in on the act, showing that liberals and conservatives have different patterns of brain activity, particularly involving the amygdala, which is a part of the brain that makes emotional responses. The idea that political views have a genetic component is now widely accepted enough. It actually has become a field of study in its own right. It's got its own name, genopolitics. Now, obviously, there isn't a gene controlling how people answer political questionnaires. That would be absurd and require us to assume that lurking in the genome is a gene that had lain dormant for millions of years waiting for party politics. There aren't going to be genes for hating gay marriage either. But there are personality traits that would likely lead to this belief, and those personality traits may be ancient, way older than modern humans.